Welcome to Shanti-Peace for Mathematics. In my previous video we have learned about the root of a complex number. So if you have given any number x plus iy power 1 by n is there, then we can calculate its roots, and it has a n roots of this. It can be represented as c omega square up to so on c omega power n minus 1, where c is equal to nth root of r0 exponential of I theta 0 upon n, which is called the principal root, and omega equal to exponential of I into 2 pi by n. So that is the value of omega, and these are the roots of the given complex number that we have learned in our previous lecture. In this lecture we are talking about a very important concept. It's called the region in a complex plane. So if you consider the function f, which is defined over a to c, where a is a subset of c, then we know that a is a domain. It's in general function. Whenever the function is defined, we can say that a is a domain. But in the analysis or complex analysis book, whenever the domain is there, they are talking about domain means it is the open plus connected set. So that is the domain in the complex analysis book. Whenever they talked about the a is a domain means it is open plus connected. Why they are calling it a domain? Because whenever in complex analysis anything they want to talk about, the set or the function has to be defined on a domain. Defined on a domain means the function has to be defined on an open plus connected set. So what do you mean by open set? What do you mean by connected set? What do you mean by region? That all the things we are talking about in this lecture. And in the complex analysis book, the domain is word, it's accepted for any function we are dealing with. With that note, we'll start with the very important concept called the region in a complex plane. To learn about the region in complex plane, first of all we should know the idea about the neighborhood, epsilon neighborhood. Probably you have learned that neighborhood concept in your F5 BSc class, also in your 12th standard also. If you have a point x0 belongs to R, it is given, then on a real line you know that this is x0, then epsilon neighborhood is nothing but the interval, open interval x0, or x0 minus epsilon to x0 plus epsilon. That will be your epsilon neighborhood of x0. That this set of points they are given in this interval, it's called the epsilon neighborhood of given point x0. The same way we need to define an epsilon neighborhood in complex plane. So if you have given a z0 belongs to C, the point that is in the complex plane. So if you consider this is as x axis and this will be your y axis, and the point z0 is here. Now the neighboring point of z0 means the points which are neighbor to this. So that is we denoted as a one disk. Here we consider one disk whose radius is epsilon. So any point in this disk, and we know that the distance between this point, if I can take this any point as a z, then the distance between z, so this distance is nothing but the mode of z minus z0, and this distance is always less than epsilon. Then we can say that this set of points which are lies on this disk with the radius epsilon, it's called the neighborhood of a point. So the epsilon neighborhood will be defined as set of all points such that mode of z minus z0 less than epsilon for any given epsilon greater than 0. The neighborhood of z0 is defined like this. For example, if I have a point 1 plus I, and if you want to calculate the 2 neighborhood of 1 plus I, then that is a set of all z such that mod of z minus 1 plus I less than 2. So if you consider z as x plus iy, then you can write as this is x minus 1 plus I y minus 1 mod of that is less than 2. And if you take square both side and modulus, if you use the definition, that is x minus 1 square y minus 1 square less than 4, you can say. So this is nothing but this disk with center 1 comma 1, so that is point here, and the radius will be 2. So the radius is 2, so that is the disk you will have, which contains inside portion of this, and the radius will be 2 that you have. This is the point 1 comma 1. So that is the neighborhood of 1 with radius 2. So that's way we can define any point. If it is given, the neighborhood of z0 is there. Now the next definition is the deleted neighborhood. So what is a deleted neighborhood for any given point z0? If epsilon greater than 0 is there, if you can remove that center portion from it, so that is the z0. If you cannot consider this z0, so you remove z0 from this, then it's called the deleted neighborhood. So by definition or mathematical notation, we can write it is strictly less than mod of z minus z0 less than epsilon. So set of all z which except z0, whatever the points is stay on that disk, it's called the deleted neighborhood of z0. Deleted means we are deleting the center from the given disk, okay, with epsilon radius. So that is the definition of the deleted neighborhood of a given point. The next definition is the interior point. A point z0, it's called interior point of a set S whenever there is some neighborhood of z0 that contains only point of S. If this is the set S and if there is a point z0 in this, if you want to say this point z0 is the interior point of the given set S, if there exists some neighborhood, so there is some points near to that which all the points of that neighborhood should lies inside the S. So in by mathematical notation, what we can write is there exists epsilon greater than 0 such that there is some neighborhood, so that z such that mod of z minus z0 less than epsilon is subset of S. So entire neighborhood, it should lies inside the S, then z0 it's called the interior point of given set. For example, if I take the example as if I have a set S as the all z x plus iy, where x is between minus 1 to 1. So what is this? Geometrically this will represent, it is the, if you consider this is as x axis, this will be as y axis. X is equal to 1 line is here, x is equal to minus 1 line is here, and the area between these two, that is this, will be this represented by this set S. And if I can say the 0 0 point is the interior point of S, because if you draw a neighborhood of that one neighborhood which with radius 1 by 2, that whole neighborhood is lies inside the set S. So that's why it is the called the interior point. But you can say that this point 1 comma 0 is not an interior point, because if you draw a neighborhood, any neighborhood of this 1 comma 0, the some portion is lies inside, the other portion, this portion is not lies inside the set S. So that's why it is the 1 comma 0 is not an interior point of the given set S. So by this example we'll move forward and we'll define the next is the exterior point of the given set. So what is your thinking about the exterior point? Naturally the point which is lies outside the set, but the definition is slightly not exactly outside, but you can say that if you can draw, if I want to say a point z0, and if you can able to draw a neighborhood of z0 in such that all the points are not lies inside the set S, then the Z0 is called the exterior point of the given set S. See, here we are talking about all the points, all the points are lies in the complex plane, and complex plane is already have a metric structure on it. That means distance is defined on a complex plane already. So, and more advanced topics of this things, that is interior point, exterior points, all sort of things, they are that you are discuss also in the topology subject that you have. Here we are discussing our concern is the points are lies in a complex plane. So, and complex plane has already a distance structure on it. So if you have a set S, if you want to say this point Z0, it's called the exterior point. If you can able to draw some neighborhood of Z0, and if you have there is no intersection with, or you can say that neighborhood is lies inside the S complement, then we can say that point Z0, it's called the exterior point of the given. So let us write down a point Z0 said to be exterior point of S when there exists a neighborhood of Z0 contains no points of S. So that means as I define, if you can able to draw some neighborhood of Z0 which having no intersection with S, so that is called the exterior point of the given set S. The next definition is we can define a boundary point. So what is a boundary point? Now you can think of a room which you are sitting in. So when you can say you are a point on the interior, you are a point on the exterior of the room, and what is the point on the boundary of the room? That means that the wall you are seated on in that room. So that wall, the points on the wall are called the boundary points of them. And then how you can define that boundary points? So the basic idea is, if you have a point on that, and if you draw a neighborhood of that point, and if there is an intersection with the set itself, and that means the intersection with the room and outside room is there, then we can say that that point is called the boundary point of the given set. So that means in other sense we can say that a point which is not interior point nor exterior point, such points are called the boundary points. So if you can say that if this is your room, if you are seated in, if the point is on the boundary, this point is neither interior point nor exterior point, so that's why this point is called the boundary point. So in mathematical terminology, if I can write down, for every epsilon greater than 0, if I have some intersection, so that is a deleted neighborhood that you can talk about. So that is the deleted neighborhood Z minus Z0 less than epsilon, intersection with S is non-empty, and if you can have the deleted neighborhood of Z0 with intersection with complement is also non-empty. So that means if you have a draw neighborhood of this point, and that neighborhood should have some intersection with the set S and its complement, that has to be some common thing between both S and its complement, then that point is called the boundary point of the given set S. For example, if I consider the set S as the set of all points mod Z less than 1, so that means what is this? Actually this point, this is the circle with the radius 1, so that is the radius 1 circle is there. Now what is the boundary point of this? The boundary point of this set of all Z such that mod Z is equal to 1, they are the boundary point of this set S. In fact, if you can have the set S1 will be, if I have Z mod Z is less than or equal to 1, then also the boundary point of this set is the same thing that we have here. For example, if I can give you an exercise that S2, find out the boundary point, exterior point and interior point of this set Z is equal to X plus IY such that minus 1 less than X less than 1. Find out the interior point, exterior point and boundary point of S2. So this is the exercise I am giving you. You can try for this. The next thing that we are discussing is open set. So when we can say the set is open, so now again we move forward to the concept that we are sitting in a room. So when I can say that that thing is I am sitting on an open area, when I can sit it on the no boundary. So no, that I am sitting in the place where there is a no boundary is there. So that is one of the concept in some of the book. They are saying that if the set is open if and only if it does not contain its boundary points. So that is one of the concept is of open set. In some of the book, that means your textbook, that is the Browner Churchill, it's defined the definition of open set in this manner. If you want to say the set S is the open set, that means every point of the set S is an interior point. So every point on the given set is interior point, then it is called the open set. So in the another way you can say that for every, if I want to say S, the set S which is a subset of a complex plane, if you want to say that this is the open set, if for every Z0 in S, so for every Z0 in S there exists some epsilon greater than 0 such that that neighborhood of this point Z0 is subset of the given set S. So for every Z0 there exists some neighborhood which contain totally entirely contained in the set S, and the such set are called the open set. For example, mod Z is less than 1 is open set, okay, because it's not containing its boundary points. Simple. Okay, if I can define the x plus iy where y is less than 1, then this is also open set. What is this set is y is 1 is here and y is less than 1, that means it is smaller than 1. So all the point which are lies below this line, and this is open set which not containing its boundary. What is the boundary point? Which are on this line, they are the boundary points of this, so it is open set. So in that sense we can say that the set is open. So next, if it is open is there, the next concept has to be closed. So when we can say the set is a closed set, the set is a closed set if its complement is open. So if you want to say S is open if and only if S complement is closed, or vice versa. If you want to say S is closed, similarly we can say S is closed if and only if S complement is open. So in other way we can say that S is closed if and only if S contains all its boundary point. That's again you can think of, you are sitting on a closed room. Closed room means there is a boundary is there. So if you want to say that the set is closed, that means a set contains all its boundary points. For example, if I say some example of a closed set, then set of all z such that mod z is less than or equal to 1, this is the set is a closed set. If I can say the set of x plus iy, if I have x is less than or equal to 1, then this is a closed set. So these are the example of a closed set. There are set which are neither open nor closed. For example, if I can say set of all x plus iy, where I can define the 1 is less than x less than or equal to 2. So this set is neither open nor closed, because in this set what is the things you have, it is x is equal to 1. So if you are, this is your y axis and this is your x axis, if this is 1 which is not included in the set, and if this is the 2 which is included in the set, so this is the set you have which does not contain, so it contains 1. So what are the boundary points of this? X is equal to 1 line and y equal to 2 line. They are the two lines which are boundary of this set. But this set is not open, neither it is a closed, because it's not contain its boundary. Now after studying this closed property, we have a closure of a given set. So it's denoted as S bar, and it is says is a closure of S. What is the closure of S? Is S union gamma of S. What is this? It is nothing but the set of all boundary points of S. So a set S bar is nothing but the closure of a set, and it is a union of set itself S and its boundary points. The next definition that we are defining is accumulation point. There are other name of this accumulation point is limit point, or some of the terms, some of the book they are also defining as cluster point. So these are the three names by which these points are known as. So what is the definition? It says that each deleted neighborhood contain at least one point of S. Each deleted neighborhood contains at least one point of S. Then that point it's called the accumulation point or limit point. That means for every epsilon greater than 0, this neighborhood, that is a deleted neighborhood, z minus z0 is then epsilon, intersection with S is non-empty. That means for every neighborhood of deleted neighborhood of z0, there is some portion is there of S. Such points are called the limit points or cluster points of given set S. Also one more thing is that if a set S is a closed set if and only if it contains all its limit point. So that is the one of the theorem I can state, but in detail proof of this theorem you will learn in your analysis 3 course, which is in the next semester. So till now you can assume this result and go further. The next concept is about the connectedness. See, connected set is here in the case of complex numbers, it's very easy to see, but when you are saying in general any arbitrary set is that connected set will have no separation, means that your set is not divided into two sets. That means A, if you have a set X which cannot be written in the form of A union B, and A intersection B is phi, also A closure intersection B is phi, and A intersection B closure is phi. If you cannot write for the set X in this form, then we can say that X is a connected. But in the case of complex analysis, the definition is very simple. So it says that every pair Z1 and Z2 can be joined by a polygon line consisting of finite number of line segments joined end to end, which lies entirely in the set S. I am repeating again. Z1 for every pair of points Z1 and Z2 in it can be joined by polygon line. That means if you have a set S, if you consider any 2 points here Z1 and Z2, and if you can join these 2 points, any pair you can join by this by some polygon lines, finite number of polygon lines, and if this polygon lines consisting of finite number of polygon lines segment joined end to end which lies entirely in the set S, then we can say that the set is connected. That means this polygon lines that which I have drawn, it has to be lies inside the set. For example, if I consider this set, if I have a one set here and if I have another set, this total set is S. If I say if I have a point S, Z1 here, Z2 here, then I can try to join this by a polygon line. Okay, but this portion from here to there, this polygon lines are not lies in this S. So that's why this set S is not connected set. If you have a pair of points, any pair of points, if you draw that finite number of polygons by joining them, and if that whole path will be lies inside the set S, then we can say that the set S is connected. It is in the topology it's called the path connected definition, but in the complex analysis structure the path connected is the equivalent to connectedness. So that's why this is the way we can define a connected definition. For example, if I consider the set Z mod Z is less than 1 is a connected set, because this is the circle with center 0 0 and radius is 1. So any 2 points here in this you can join by polygon lines, and all the polygon lines are on lies inside the set. But this set is not connected if I define as Z is equal to x plus iy. If x is less than 0 and x I am taking between 1 to 2. So what is this set is? X is less than 0, that means this portion. X is between 1 and 2, so that is, if I can have, this is x is equal to 1 and this will be x is equal to 2, and this is your y axis, this is your x axis. This set is consisting of these points here and the points which are in this strip. Now if you have one point here on this side and one point here, then if you try to join by a polygon lines, then this portion which is not lies inside the set S. So that's why this set S is not connected. Next very important definition is called the domain. As I talked in the earlier in my lecture, what do you mean by domain is connected open set. So it is connected plus open set. If you have that set, it's called the domain. So for example, what is domain? The domain is the set of all Z mod Z is less than 1. This is the domain. The annulus, that is mod set of all Z less than 1 less than mod Z less than 2, is a domain. This is known as annulus. What do you mean by annulus? Annulus, it is nothing but the area between the two circles. If you have, this is the disk with the radius 2, this will be the disk with the radius 1. The area between them, this is called the annulus. This is the name of this portion, it's called the annulus. And it is a domain because it is connected. Any 2 point on this is you join by a polygon line, it is connected, and also it is open because it's not contain its boundary points. Every neighborhood is a domain. If you have a neighborhood, it's obviously it is open set and it is a domain, that you can say. Now the next one is a region, which is a title of our talk. A region is a domain together with some, none, or all its boundary points. It's referred to a region. So I am repeating again, a domain together with some, none, or all its boundary points is referred to a region. So all the sets which I have talked about, all of them are regions. That means this set is a region, this set is a region. I can say this set is also region, set of all Z mod Z is less than or equal to 1. This is also region because it contains its boundary and it's connected. So next definition that we have is a bounded set. That is the last definition of this talk. So what is a bounded set? If you want to say a set is bounded, if every points of that set S lies inside some circle mod Z equal to R, otherwise it's called the unbounded. For example, if I have this set S, if I want to say this is the set S, if I want to say this set S is a bounded set, if it is lies inside some radius R. So if there is some radius is R, if the set S is totally lies inside this circle or this disk with the radius R, then it's called the bounded set. For example, I can say that the all Z such that mod Z is less than 20 is a bounded set, but the set all Z such that if your X is between 1 and 2, it is not bounded set, because it's, if you can see in the figure, if this is your X axis and this will be your Y axis, if this is the line X is equal to 1, this will be the line X is equal to 2, and this set you have here, which is represented by this, the points on this strip, and you cannot have any circle with center 0 0 and radius r, so that this whole set, that means you cannot draw such circle, the whole set is lies inside, because there are some portion and trying to draw, it's going out from that circle. So that's why this set is not a bounded set. That's it. I'm giving you some exercise here that you can try for whatever the discussion we have did today. Exercise: stretch the following sets and determine which are domain open, close, bounded, mode z less than 2 plus I greater than 1. This is the first example. Second example, imaginary part of z is greater than 1. Third example, mode z minus 4 is greater than or equal to 4. Z, mode z. Fourth, the argument of z is less than or equal to pi by 4. So that's it for today's lecture. Let us recall what we have did in this lecture. First, we have defined the neighborhood, epsilon neighborhood, then epsilon deleted neighborhood, then we have defined about the interior point, then we have defined the exterior point, then we have defined about open set, closed set, boundary points, limit point or emulation point or cluster point. We have defined about the domain, region, bounded set. So all sort of things we have discussed in this lecture. Hope you have liked this video. If you have liked this video, please press the like button. If you have any question, you have any comments, please do it in comment box. Thank you very much for listening me. Bye bye. Sayonara.